Okay, this is problem 13 from chapter 19, and it's about teenage drivers. So what we're going to do is we're going to calculate a confidence interval. So it sounds like the information given sounds like information from a study, not a survey, not really definitely not an experiment. So an insurance company checks police records. So think records that are on file. So retrospective study on 582 accidents. So I'm just going to record some of this stuff. So the sample size is 582, and notes that teenagers were involved 91 times. So success, in a strange way, is going to be defined as accidents that involve teenagers. Okay, so from here we can see that our p hat is going to be 91 out of 582. And let's see, I already did that. That's going to be 0.1564. So typically I round, or I'll use percents, so it's 15.6%. So, but since I'm going to use this to do computations, I'm going to take it out at least 4 decimal places. So Q hat then is 1 minus P hat. So that's going to be, let me just do that real quick. 1 minus 0.1564. So that comes out to be 0.8436. Okay, so before we can go too far, we need to check the conditions to make sure it makes sense to use a normal model. So it didn't ask you to check the conditions, so be careful. Don't fall into that trap of not checking the conditions. Sooner or later, the conditions won't be satisfied. So, plausible independence condition. So here, let's just say something like there is no reason to believe that that accidents selected at random would relate to one another. Okay, so in other words, they should be independent if we're just selecting them from records. The random sample condition, so yes, but don't just say yes. The insurance, right? Isn't that what they said? The insurance company checks police records at random. So yes, the insurance company selected the accidents at random. Okay. The 10% condition. Well, let's see. It makes sense that 582 accidents is less than, unfortunately, 10% of all accidents. Okay, they didn't specify type of injury, did they? So this would just be, these could be fender benders or they could be major injury accidents. It didn't specify. So I think we're in good shape by making this claim. I don't think we're stretching anything. Okay, so now Success failure condition, well, that we want to make sure that the sample size is large enough. So we want to make sure that n times p hat is greater than 10 and n times q hat is greater than or equal to 10. So n is 5, 2 times, what was it? 0.1564. 0.1564. I want to make sure this condition is true, and then 582 times 0.8 something, 8436. And I haven't done this computation, so I'll just do it right now. 582 times 0.1564 is approximately 91, so that's greater than 10. And then this is going to clearly be bigger. That is approximately 490, so that's greater than or equal to 10. Okay, so therefore the sample is large enough. Okay, so let's see. The conditions are met. So we can use a 1 proportion z interval to do what? To estimate the number of accidents involving you-know-who teen age drivers. Okay, so now we're sort of making a transition from checking the conditions to doing the computations, and we're sort of suggesting, we're kind of introducing the model. So I'm always in teacher mode, so the confidence interval is always an estimate plus or minus a margin of error. Okay, so the margin of error is just equal to z star times the standard error of p hat. So this is going to be, our estimate is p hat plus or minus z star times the square root of p hat times q hat divided by n. That's what the standard error is right here. Okay, so this is 0.15. Unfortunately, I have a bad memory, so 1564 plus or minus, I'll come back to this in a second, 0.1564 times 0.8, is it 8436, all divided by the sample size, 582. And then since we're asked to do, what was it, a 95% confidence interval, so if you don't remember how to do that, it's not that hard. Just draw a little picture and think through it. So this is 95% of the area under the curve. So this area would have to be 0.025 on this side, since they're symmetric. So z star is equal to the calculator function inverse norm of 0.025. Now you'll get a negative number. You'll get negative 1.960, but that's okay. Just use the positive because it doesn't matter. the way we do plus or minus here. So it's 1.960. Alright, and so this becomes, at least what I get, plus or minus 1.960 times 0.0150. So again, don't round too much until the end. That's the key thing. So the confidence interval that I get is 12.7% to 18.6%. Okay, so they ask, the next question is, what does this mean? So what it means is we are 95% confident that the true proportion of teen age drivers involved in car accidents is between 12.7% and 18.6%. So we've trapped it between those two values. Okay? So let's see. Explain what 95% means, okay, in this context. So what that means is about 95% of random samples of size 582 will produce intervals that contain the true proportion of teen age drivers involved in accidents. Okay, so that takes a while to sort of comprehend. So another way to say it is, if we did 100 confidence intervals with 95% confidence intervals with n equal to 582, we'd expect 95 of them, about 95 of them, to capture the true proportion. So we wouldn't be surprised if 5% of them didn't capture the true proportion. That's another way of putting it. Okay, so I don't want to drag this video out too much longer, but there's one last part. A politician urging tighter restrictions on driver licenses issued to teens says, in one of every 5 auto accidents, a teenager is behind the wheel. Does your confidence interval support or contradict this statement? Okay, so, well, what you would want to do is 1 out of 5 is, well, it's not even approximate, it's 20%. So if you look at the confidence interval, you can see that 20% is not in the interval. Okay, so we would say something to the effect that the confidence interval contradicts the assertion of the politician. Okay? Sorry about my sloppy writing. Because it does not fall between the interval, or within, between. Let's just say within. Okay, so hold off making comments about the slimy, sleazy politician that takes advantage of the fact that teenagers don't vote and makes claims about them that are false. Don't go there, even though it's tempting. Stick to the evidence and take advantage of the fact that you have a basis for what you're saying and the politician doesn't have a basis for what he or she is saying. Okay, good luck with this. Let me know if you have questions.